Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, January 5th, 2022, Wednesday, and this is 4:08 a.m. in morning time. दिस इज इंजीनियर सूरज सिंह। मैं हूं भारत से, इंडिया से इंजीनियर सूरज सिंह। सुबह के 4:09। आज जनवरी 5, 2022, दिन बुधवार। टाइटल इज क्वालिटी अगेन एज यूजुअल, क्वालिटी इंटेंसिव टॉक, सेफ्टी इंटेंसिव टॉक, concrete particularly, which is very important material, and it is civil field engineering, life engineers and AnnexSL contracts etc. What are disputes? Main focus on quality, safety and contracts, main focus. And this is your, you can see my credential certificates that announce to people. Such certificates many people have around world, and also in our country. It may be professional engineer certification, it may be chartered engineer certifications. I think that is held by many lakhs people in our country and around world. And also corporate membership certificates, which means membership of institutions, and particularly institutions which is chartered one. And also quality, that is quality in our country, deliberation on this that is conducted by my efforts and by your acceptance every day. It's maybe some people think that I do it daily, and you can write to me on this email ID, that is Suraj SURAJ _ engineer ENGINEER @yahoo.co.uk. It is up to you if you want to write, if you wish to write, if you raise some question about this talk, if you want to suggest something, for making it much more better or making this time useful, you are most welcome to write to this email ID, or you can send message through this site. It's up to you. Of course, this name and title are here, and also you can say these certificates you can refer to. You may know about them, I'm sure, and the certificates are there. An issue of quality, which I think is burning one all time for me, and I think it is better to be clear about what I'm talking. I'm not talking something in vain. This talk is for me, of course, it's very important because quality is a question mark. I say actually in our country it's not only a question mark but also mark of exclamation, and that's one reason that I put mark of exclamations many times, just to invite your attention, or you can say import your attention, and you should also import others' attention towards state of quality, or you can say non-existence of required quality in our nation. Quality means how work should be done, to what grade, to what specifications work should comply with. It may be manufacturing, it may be production, it may be industrial product, it may be non-industrial product, it may be daily use product, it may be construction product, it may be short living product, it may be long living product, or it may be whatever service given by someone to someone. You service someone else services you. It's one and same thing everywhere. Work is done. Work is done in terms of measurement of some unit, or it may not be susceptible to measurements. It doesn't make a difference as far as quality is related. What is quality? Everybody knows definition of quality, but I try to differentiate it than common definition. Quality in profession, of course, when you call something is professional, what does it mean? Professional or profession means quality plus quality plus quality plus upgraded quality plus upgraded quality plus super quality. Or you can say quality continues improving, it's a standard when you say it is professional. And when someone is professional, this clearly indicates that that person has certain special quality, or you can say has got certain special advancement in that field, has of course obtained special knowledge, in-depth knowledge of that field, and that knowledge is not easy one to grasp. It takes time, studies, thinking, concentrations, long journey to get to certain marks, which remains much above than ordinary educational or academical marks. We can get education, we can achieve degrees, we can do research, we can do whatever in our academical spectrum. But when it comes to field of working, or you can say applications of working, situation changes, completely changes, and individuality, opportunity, efforts, concentration, all come into picture, which are distant from stage when you passed your education qualification. Education has its importance, but application of what you learn in your education is much more significant and important. Quality is developed by that procedures. What did you achieve? If you achieve something, you have to apply that one for improvement. As we say in our profession, there is this simple terminology, or you can say string, say plan, do, check, and improve. We say plan something, do that one which you planned, and then what have you done? Check it. And when you check it yourself, you shall certainly find some error or something missing, and you correct that error or fill in that something which you missed in. Might be cause some bridge or gap or gulf, you have to fill in that, bridge that, and then you further improve and improve and improve. So it never ever stops. It continues doing its job, and that never ever stops. You do 10 times, you do 15 times, you do 20 times, or how many number of times you can do, you shall certainly find some improvement, and you shall, of course, you shall run efficiently on that. You shall save time, you shall augment level of quality on that item, but it depends on if you follow that track. If you leave aside, you may not do what you wanted or you plan to do. This means quality always improves. You can never put period on that there's a period or comma. You're not going to cross that, bypass that. Quality always continues like profession does. Profession, occupation, vocation are all different terminology. When you say occupation, it's not profession. Of course, it is trade, you can say, not profession. When I say profession, this means in-depth study, in-depth advancement, knowing more and more, evolving more and more, thinking more and more, and applying more and more. You learn one formula, say, it can be applied thousands times, and every time you get different results depending on parameters you put in, and it brings something different. Engineering is that field where nothing is permanently fixed. It depends on what activity is done, how it is done, its formula one or its empirical one, if it's derived formula or it is underived formula. It moves on improved path or it moves on research detrimental part or research improved part, both ways. We in engineering, particularly in basics engineering that we can say, particularly basics I mean to say, which cannot be avoided. Example, civil engineering, mechanical engineering, electrical engineering and some other. These are elementary engineering using which world starts, and you can say others are supportive engineering which make business. When I'm talking of basics, I'm talking of elementary world where we can start our living, we can come out from very primary time to current times. Engineering comes into picture. Engineering means life. Engineering means life because life itself indirectly is a kind of engineering. And you can say engineers, I say life engineers. It doesn't matter you work or you don't work. It doesn't matter you think or don't think. But once you do engineering, it never stops. It doesn't matter you get payment or no payment, but engineering goes on and on. It may be working engineering, or manufacturing engineering, or construction engineering, or operational engineering, or maintenance engineering, or it may be, you can say, some other kind of engineering. Engineer has no limit. Engineer is a world where thoughts continue to go on, dreams continue to come in, and we have to understand them, read them. No drawing is same. When I'm talking of drawing of engineering, no drawing is same, no mechanical drawing is same, no electrical drawing is same. Yes, theory is same, and sometimes without theory we do work, and that is called empirical work, where depending on time, depending on circumstances, assessment is done. This means individuality comes into play. And when individuality comes into play, individual quality remains very important. If individual person, individual material, individual organization, everyone can be at individual level. That level acts as a unit. Sometimes it becomes a unit. And that unit, just like we use unit of measurement, that unit can be called unit of consideration. And that consideration is very important. We consider, then we assume, or we use some reference. After that we say, this is a result, this is acceptable or not acceptable. A check can be done on that. Our engineering world is different. It makes life, that is certain. Engineering starts life, engineering makes life. And in life, we have two ways. Either just live, survive, or you have to improve. Improvement has no limit. And quality relates to improvement. Quality is not a terminology in itself. You can say it's engineering its quality. Your brain power is quality producer. Brain has no limit. Same way, quality has no limit. You cannot quantify quality, but you can quantify quantum of material you produce. This is only difference. Quality of different grades is called quality, and grades are unlimited, though we classify them in our codes. But other than that, you can say values go on being added. You can add whatever value to something. It's not decorative value, but it is its service value, its durability value. Quality means you have to do something in comparison to other and in relation to other, or on a datum line that you say this is minimum requirement and there is no limit for maximum requirement. No one likes that you can deliver something more expensive than what you are paid for. Nobody demands that. But it remains as reference. This is what is required to be done. Are you doing that? That's the point where we have to stand. And that's why questions always arise, as I talked before also. There can be no limit on any question. We use materials in our works, we use equipment, machines, tools, and we use human power. In works, and particularly in civil engineering world, which involves majority of constructions where there is no classification can be done. No repetition can be done because everything is different. If you compare 2 or 3 drawings, you will find all different at least in foundations or in hues or in plan or in elevation. If it is not typical, you will find differences. For example, when you say mechanical, there is a machine. Many machines can be produced of same design, but you cannot change design for every machine. But in civil engineering, in construction engineering, you cannot design same structure all the time. Okay, I produce 100 structures as such. That doesn't work in civil engineering. In civil engineering, every structure is different. Every structural world is different. Even if you try to keep plans same, foundation cannot remain same. Soil at every structure, below soil at every structure is different. One structure is here, another structure is elsewhere. Both would be different, at least in foundation. And if local conditions are not same, are not typical, then superstructure, or you can say structure above ground, also varies in design. This means you cannot simplify your design to typical requirement just like it happens in mechanical world. We have to see differences in engineering. Therefore, branches have been created. But originally, whatever branch you work in, whatever industry you work in, wherever you work in, most important point is requirement of quality. Quality is very significant one, and if it cannot be controlled, it cannot be held, it cannot work properly, then we do not do justice. Quality has to be maintained at least at some point. That point can be called specification. Whatever specification we design for something, we have to stick to that one for purpose of doing. As I always say, we always say that this is a specification for this job, this is a specification for that job. That is reality. We decide ourselves what is specification, we decide ourselves everything. There can be questions then, why we are raising quality? We are raising quality because we decide something, we define something, but when you do something that doesn't comply to that definition is our own, material is our own, but we do not strictly meet that requirement. It's not because we cannot do it, It's because of individuality factor. Some persons cannot understand what is to be done, and they do what they have been doing, what one has been doing. Documents are prepared and published. Documents are done, clear instructions are given in those, and if these are not given, person who do on work, they conduct work, carry out work, they don't read them. Or you can say, individuals become lazy, don't care about that. Problem erupts in, problems come into picture. And that's where we say it's a problem. So we can raise question, what about major material? What about major material? Concrete in structure. What about major materials that are permanently included in structures and buildings? What about engineering materials being used to produce various hundreds parts, goods in manufacturing? We raise these points. Material, machines, and you can say various parts in structures, assembly of so many materials at one point, and then operations we call them, activities we call them everything. In civil engineering, major material are, you can say, concrete, bricks, or you can say finishing items. Though there is steel also, structural steel world, but in structural steel, plus point is that civil engineer does not manufacture it. It's different industry. Structural steel is manufactured in industries which remain generally in control of mechanical people. So when structural steel comes into picture, you are given a material, a selected one, but you don't have any control on its in manufacturing, its production, and where difference lies in. When you consider concrete to be used or included in a structure, then responsibility augments. If I am given a project of concrete, it's my responsibility to take care of concrete. But when I am given a project that it's not concrete, it is structural steel, or it is some other material. For example, it's only brick and old style houses where concrete was not used. In that case, I think engineers were not required. Engineers were not required because there was repetitive engineering in those cases. Or you can say conventional engineering. There's a time when you used to stonework, you to do later on brickwork. But when structural engineering comes into play, generally we call them by title structures or structural engineering, which is a part of civil engineering itself. Civil engineering is a wide one, and what we call ourselves that structure is a very important item. Structure means we have to make sure it performs successfully. And the structure doesn't mean a term only, it's unity of body of a building, or you can say it's framework of a building, of a structure, of some you can say whatever you construct. A structure takes load. Whatever actions, forces are applied or imposed on structure, these forces are taken by structure, registered by structure, transferred by structure to further down. So finally it goes to soil level, and then it is dispersed forever into soil, and which we cannot call it back. That performance is very important, and with that performance we design for that one, and it should be done. First of all, design should be done accordingly, and that we can say it's a quality design. Same way we have to produce it on sites or in real world, and we can say that is quality work. Here I am not here to define quality. I am here to stress engineer is very important professional who has learned a lot in engineering. And it's not only one engineering branch. Mainly 4 or 5 engineering branches come together for some work, for public use, for private use. When we produce a building, it's not civil engineer alone. Yes, civil engineer does it at major percentage. Civil engineer includes architect as far as I am concerned. It's not legal, it's just for consideration. For me, civil engineer, architect, structural engineer remain in same group. You can say, I'm just titling them engineer or civil engineer. Means building engineer you can say, rather than civil or electrical or building engineer. Then mechanical engineer, which is a permanent support, full support. Electrical engineer is a full support to buildings, to structures. Others are also there like security, or you can say like a part of agriculture, horticulture, or so like decorative types, doors, windows, or such systems which also secure buildings or structures. So my consideration for quality goes to these people. I'm not importing here other services which can be added at whatever time. When we talk of quality, it's not only here in this country, it applies all over the world, but particularly I'm referring it to our country because I observe our people do not value quality. They say quality, and it is claimed, quality is claimed, but it's not realized. So my question always remains, where does quality stand? What is its status? And answer I get, there is no definition of status of quality. Maybe you become sick by listening all time why I talk of quality. Because you don't realize. We have to, again and again I explain, we have to know difference. We have to know difference of use of product. When you buy some item that doesn't exist next day, for example, you buy vegetable, you care for quality, oh this is rotten, this is smelling offensively, this is not worth, or you throw it or you don't buy it. When you buy something else, you say, okay, this is not consumable, so I do not accept this. But when you want to buy something big, you can say, you have to think something big, you have to consider something big for that, but you do not consider. That is the point. Say you want to buy a car, you are not sure about car specifications, so you want to see, okay, what is color of car, what is mileage of car, how decorated it is inside. Likewise, it's up to you. Rarely you want to know what is power of engine, what is indicated horsepower of its engine, what is brake horsepower of this engine. Because performance of car doesn't depend on its color. It doesn't depend on its facilities. It doesn't depend on its internal architecture. Performance of a vehicle depends upon efficiency of its engine. How does it work? What is its mechanism? And how long can it serve you efficiently? And how does it relate, its functioning relate to environment? Those points are rarely understood because everybody is not technical. People don't understand what is horsepower, indicative or brake. But that is very important point. One car can run on 40 HP, one can run on, you can say, 200 HP. That is machine 300 HP. People do not want to know this. They just want attractive car, attractive architecture, internal as well as external, the more interested in cleaning it and showing it to people, say it's beautiful, it's clean. Okay, that is point of keeping it. Just like we say housekeeping, it's a point of public keeping, you can say, because car is public, it's exposed, it can't remain indoors. That is one part. Another part is that you spend money on that because of so many reasons. You want expensive car or status, so you ignore quality there. You buy whatever vehicle, you want to enjoy that for a couple of years, and even say it's not quality one. You have to dispose it after say 2, 3, 4, 5 years, or exchange it or buy another one. But that is limited. If you even your money goes waste, you use to some extent, you can say, okay, I used it for 2 years, 3 years. I enjoyed its driving. I enjoy this writing. Same way, there are many other materials which do not impact on your life forever. But there is one material. You may say material, or you may say your destiny, to which you can call your destiny, because destiny means your lifelong or major part. It comes into say your house, your building, or what you say where, or you can say which for buying you have to spend major portion of your life savings. You buy some house, you purchase it either built or you give it to someone to build it. It's your whole life saving that goes into that project. You buy something from promoter or from developer, you do not know what to ask, what to check, but you say, okay, this company has many engineers, they know everything, and whatever prospective or whatever proposal says, or whatever sales marketing standard says, okay, they are saying we shall give you this, this and this, and you are happy, okay, this is fine, they shall give this. But you see, market trend, publicity is one part of life, but reality of material is different part of life. You do not care about how structure shall be done. You care about only what facilities shall be provided to you. How attraction of bathroom, what type of doors, windows, or you can say how convenient it is to live in that building. Other than that, you have no intention, if you are not technical, to know about that. What is concrete? Concrete is very important part of structures, particularly concrete buildings. Concrete bricks, or you can say concrete blocks and finishing items. There are immense, many. How many persons are aware of these? Very few. People watch construction, but they do not know what it is. Majority of people do not know what for steel reinforcement is used, what for concrete is, what is concrete. For them, it's a mix of few materials. That's it. People are not aware, if they are not technical or engineer or in engineering field, what is concrete, what is brick, what is stone. In fact, they do not know it. They know it is a stone, they know it is concrete, but what is behind that? Why we are using that? These people are not aware, and they cannot be. Until either you teach them, you disseminate this information to public, but that doesn't happen. There is no media that can publish for public awareness, and whatever media are there, they are such high profile that public cannot reach them and they cannot reach public both ways. They are so highly qualified that they often condone all this requirement. But my thought is different. My policy is different. Engineering should reach public. What has to be done? Public should know. Only then we can say quality can be understood. As my question is, what is provision by government to force productions and constructions be delivered with quality compliance? What is reason that quality requirement is being ignored by nation? What reason does exist that engineers are not able to conduct required role towards quality domain? These are certain questions, very few questions, and there can be many more questions. As I said beginning, where does quality exist? Why it does not exist? There can be more questions. Who is responsible for that? What about major material, concrete in structure? What about major materials that are permanently included in structures and buildings? What about engineering materials being used to produce various hundreds of parts and goods in manufacturing? And these all relate to state of quality in our country, Bharat, India, and also you can say many other countries. I have written some again. No seriousness has been observed among engineers from all branches about quality requirement with no known reason. If there is some issue, there should be some reason, because there is no reason in this. That's why you can say there's no issue. That is mathematical consideration and equation, but issue exists. Because no material in market is available that can give quality performance. No material in markets is available that can give quality performance, yet quality mark is owned by every material manufacturer. How is it possible? This means that quality certification is not perfect, it's not reliable, or it is just for name's sake. Whether or not it is private or it is government, quality exists nowhere, it is certain for sure. It exists only in lip services, or in publicity, or in just fake claims, just to deceive purchaser, so that destination is reached that purchaser buys your material, your product. And who is responsible? Partly you can say engineers have forgotten quality because it is due to individuality or due to whatever reasons, and also that engineers did not study it properly and quality could not be understood or it could not be taught by professors because they themselves may not know what quality means. It means quality in education is absent. This means quality of education in itself is absent. Quality cannot be taught in education. I think that's right. Because years in education, for example, engineering first degree, which may be 4 or 5 years, then second degree, which can be 1.5 years, and then final degree, that is doctorate, can be couple of years. In this period, maybe quality remains off tracks. They know just quantification, just certification of degrees, but it is understood that quality is included in that. But it is also understood that quality is not included in that, or it's not properly understood. Design ways, theory ways, and whatever ways. I do not condemn that. It's no good. Whatever we learn is always for good. But engineering starts not at learning in university. That's only academical part. And academics does not mean life. Academic is just academic. Of course, it imports your mind. Your mind develops. It is great. You know something which you did not know before 5 years of your passing. You know something, and that's brilliant. Of course, some part you know, some part you do not know. It happens. But when you enter field, you get an opportunity. Real education starts from there. Real education, which we can say field learning. It may be design, execution, planning, quantification, whatever. Actual learning starts from there because we have all resources to our disposal. We start using materials, we start using how to engage people, what is output, how they should work, what's work procedures, and also how to use equipment and machine. And all these, in fact, you can say, you are given authority, maybe dependent one, to utilize this economical part of our life. And it is really very important that we say I'm sure that engineers have forgotten quality in this case, but when we start working, we are given a chance to know it. We are given every chance to know quality in work. But because maybe we have some pressures, or we do not know procedures, we do not know how to do it, or we are not given a guidance how to do it. In that case, either we do wrong, or we do whatever is told, or we do not. And whoever tells us what to do, maybe that person itself is not clear about what to do. I say every organization is certified by quality system, but existence of quality is poor. Why? And another is government least bothers because it does not care for engineering and engineering products, and companies least bother because they are commerce and business oriented and believe in short-cut earning methods. These are certain points we have to consider. No long-term vision, we can say, and professional engineers never ever bother because they have gotten no independent standing and are unable to fight against abuse of quality system and tacitly support misleading publicity. So we can say it's a complex of questions. Complexity of questions we are talking of. But where does problem lie? My question is that. Where does problem lie? Where actually problem is and why we have been ignoring it? It's very simple answer I can say. Again I say, when you learn engineering, when one becomes professional, one must be given, you can say, value. It's not that you always remain infant. When you do engineer's job, it may be lowest one, but it is responsible oriented. Engineer means responsible oriented because it's part of life, part of economy. No economy in world can develop. No economy in world can move if engineers cannot keep themselves well oriented, well trained, well used to job, and reliability factor remains higher. Engineer means use all these resources, as we said, material, human resources, machine resources, time resource, money resource, value resource, and to meet demand with supply, and to meet supply with demand. This is very complex statement, you can say, but this is reality. You cannot simply think of percentage of profit. You have to think of percentage of what is given back. If I buy something, I have to pay money. Say I pay 100 to someone, and if I get back only 50, shall I be happy? That is one point. If I pay 100, I get 90 back. What level of happiness I shall have? You can know. If I get my money full back, I'll be more happy. But if my money doesn't come even to 20, 30, 40, then certainly I shall be very sad. And that's why I say, we generally say in English language, I'm paying you this, you pay me back. You pay me back means what? What for I am giving you? You pay me back in different terms. Exchange. You can keep your service charges or your profit margin and pay me back in transformed service. If I pay you money, you give me back material of that value. This is very simple. Means you have to give me back my money in quality terms, in material terms. If I get only good and not quality, it's no use. But point is, production is not in my hands. Quality is not in my hands. It's beyond my control, even if I am employed somewhere. I cannot dictate every word. It is someone else who wants to make money, or it is someone else who stops me from doing everything what I intend to do, or I am dictated by some other procedure. You have to confine to this procedure, and that's our responsibility. So what I mean to say, confinement, limitations, dictation, so many points are involved, and these act like some force on structure. I can't exclusively say that only engineers are responsible. I should say a kind of system or part of system is responsible. When we say system and quality, it means whole system, all procedures. It's not simply engineering world. It involves commercial world, trade world, and wherever management or organization, you can say. Management and engineering conflict are always known. Engineering is reality, management is just organization. There's a difference. How to organize is one part of life, and how to do engineering work is another part of life, though engineering is also organization, but engineering involves something factual. If factual considerations are ignored, engineering cannot be done. 2 plus 2 equals 4. This is what calculations, what mathematics says. But 2 plus 2 can be 5 when commerce comes into picture. Management that we call is something forced to do it without logic. Management says you have to manage. I use this term many times. People use, and they even told me, "Oh, you manage it." Means it's a style. First off, say, "Okay, frankly manage it." I say, "You have to manage it." Why you can't manage it? All these three are different meanings. tone of speaking, say manage it, do it whatever way you can do it, by hook or by crook. You got my point? You have to manage it. Oh, you fail to manage it. We say that. My God, you don't know how to manage. You can't manage. Every sentence has variance of meanings. This management term really is very criminal term, I can say. Really, it's a criminal term. It sends different tunes, different tones. Manage. Nabur se organize. Because both are different meaning. Manage or organize. Or you can organize management or organization manager. Engineering is not management, to be very frank. Because management is not production. Management is not construction. Management is just imagination. Do it whatever way you want to do it. They won't say clearly. It happens many times when I used to work in field. I could not understand what is management in fact. Because I really could never understand in my life what is management. But management is very important term. People value it. Project management, business management, MBA, likewise. They shift from reality to management. Management means whatever is available, do it. Do it whatever you want to do, but engineering does not say that, remember. Management does not know reality of life. Engineering is based on reality. I say engineering is reality because engineering depends on principles, it depends on formula, it depends on theory, it depends on analysis, it depends on to meet requirement. None of these are involved in management. Till now, nobody has defined clearly what is management. As I said, my seniors sometimes in my career who were above my position, and they used to enjoy saying, what you are doing after all? You got some questions, you got some correspondence, you mark it to this person, this one, you have 10 correspondences or communication marked to 10 persons, then you collect information from them and combine that and sell to someone. This is management. Yes, this is management. Now, what's your contribution? If you are extracting information from various persons and just interpreting that information and compiling it to some different or precise form, and you pass out in your seniors, then what is your contribution at that? Just interpretation? It's the point. What is your contribution? In engineering, contribution always exists. If contribution does not exist, engineering does not exist. But in management, you cannot define what is management, but you can define what is engineering. And when you can define engineering, you can define quality. But in management, you cannot define anything. You cannot define quality. You can only define. You can only define your own definition, nothing else. I'm not against management. I'm not in favor of engineering. As a person, because I have to use nature into engineering world, that's why I depend on reality. If I don't believe in reality, I cannot construct anything. Reality, I cannot construct anything. There's so many jokes in management. I have seen many MBAs. Please don't take it otherwise. I've seen many MBAs, MBAs graduates. They sometimes, when I used to go for interview for some position, project manager, for example, I saw sometimes many MBA candidates. By chance, I had interaction with them. What's your qualification? What for you come? I am MBA. I have come for position of project manager. Oh, is that? Are you engineer? No, I'm MBA. What for you come here? Oh, is position of project manager, and I consider myself a suitable candidate for that. If I ask, what's your role in this? This is engineering construction project. Oh, no, I can do many things in that. I can arrange finances, I can do that, I can arrange human resources. But no one said I can do project. And I ask many PMPs, you will deliver project? Yes, I will deliver project. But you're not qualified one, you're not engineer one. Oh, why should I know engineering? I'm a disposer. I just take this information from this engineer and from that engineer and pass it on to other. And then I say deliver. Oh, I see. So what I think, you are just going to collect information and pass it to other one. Is this engineering? Is this management? Yes, this is management. Oh my God. You don't have engineering knowledge and you want to lead engineering project. How competent is this? How consistent is this? How compatible is this? It's same thing, you are an administrator. You want to lead that work. Overall you are, and you know nothing about work. It's not same thing. As it happens in our country, there's a position IAS. They call themselves administrators, like MBAs in technical world. And they say we are leaders in work, while they know nothing about work. That's what I'm saying. How can you get quality in that case? Quality is a specialization of particular field. Management has got no specialization except talking, and you can say isolating themselves. I am manager, I am administrator. But engineer cannot isolate itself, because engineer has to deliver. Manager has not to deliver, administrator has not to deliver, but engineer has to deliver. Engineer is practically hard work, intelligent work, because engineer has to stand in sun, in heat, in rain, in storm, in cold, and also to think and to deliver and to comply with whatever requirements. Nothing of this sort apply to management or administration. That's the only difference. Means you have to suffer from these adversities as well as no adversities. It may be whatever sector, construction or manufacturing or whatever. You have to dispose of your responsibility technically, practically, and you have to give results. And somebody has to sell it. This is what it is. You do everything to your bodies, to your mind, depending on these, and somebody has to sell it. That somebody has to sell it, you can say is management or administration, and you have to digest every problem, that is engineering. I can classify that way. This is spectrum, this is status. You may criticize my statement, doesn't matter, but I am analyst. I am analyst. Every engineer is analyst, technical analyst, calculative analyst, figurative. I can say this is what it is. You have to combine these two. Analysis is fundamental right of an engineer. If engineer cannot analyze, because engineer knows facts, engineer can do best analysis. No other person can do it. and every engineer does it. Only problem lies when engineer analyzes, does analysis, its results are not accepted by others because these results pinch others. Pinch others. When engineer talks of quality, people think why he talks of. I want to do business. I want to make money. Oh no, it's not viable. You are talking to add cost onto this and reduce my profit margin. I can't increase cost because of market economy, because of competition. You contemplate on competition. Yes, you contemplate. Competition of what? Competition of price. Right? Okay, one time you sell it. You're happy, you got price. But when that consumer, when that end user fails to find what you delivered is worth, that consumer shall not be back to you and certainly go to someone else. So rather than you think you're not getting money, you're getting margin, here you're losing everything. And because you forced the engineer to forget quality, what shall that engineer do? Here, I say engineer is scapegoat. Because of you, if something happens wrong, oh, you are responsible, engineer did it. But when you earn money by cheating, by falsely stating your material is quality one, what is fault of that engineer? I always say every organization is certified by quality system. And what is that system? I think people have forgotten it. People have forgotten it. What is system? It started with quality system, unfortunately not with quality. Had it been started with quality, the system would have developed automatically, but it happens reverse. It may be with Sigma, it may be with IS9000, it may be with standardization. When we stress on system, in fact we forget quality. Though quality is quality, you cannot oppose system, you cannot oppose criteria, it is defined one. Why then quality falls? It falls because of overconfidence in system. I can simply say overconfidence of quality system. When we say I'm certified, I think it's my basic right. I think that I've been marked certified. I forget it was certified subject to conditions, which are understood, subject to performance. And we forget that we are under observation. But who is observing? That person may not itself be quality one. Okay, this agent certified me, but what is this agent? We never say, okay, we got certificate, and with highest degree of pride, we announce that. We post in walls, we publish it. We have got this certification, ISO 9001, 2015, or before that 2008. And we used to sell ourselves. It's a sales certificate, you can say, right? It's duty of that organizer who certifies certain organization. They have been performing with quality, but that certifier may not 100% know you, or at random they check. But I'm not blaming that also. I'm not blaming system also. I am blaming approach. System is certified, not your performance. System is certified, not your product. Should I blame system? I say no. Should I blame quality system? I say no. I should blame trust. This person who has been certified is not trustworthy, because that person thinks I am certified now, nobody can question me. But I say you are certified at some stage, It doesn't mean you are certified at every moment. At that stage, you are checked, you are examined, but it is your responsibility to continue it. It's neither responsibility of that system, it's neither responsibility of that qualifier. It is your responsibility to deliver quality product. Quality system means product must be quality oriented. They even say quality system doesn't guarantee any product quality. That's right, I accept that. Product quality cannot come by use of system, it comes by use of manufacturing and by use of controls. So quality system alone is not performing, performer. It's only indicative. It's only indicative, I say. It only tells this company or this organization can be relied upon. But it's no certification to guarantee of product quality. It's only keep aside system, check product, use product, and then know it is quality product or it is not quality product. I say nobody bothers. Government least bothers because government is not paying. Government doesn't pay for your product. It's you. Government does not care for engineering, though it's first duty for government to care engineering because engineering makes a nation. Engineering raises economy or engineering loses economy. If product is not quality one, nobody shall buy your product, at least at international level. Other countries won't buy your product. Maybe your people can consume it at low prices, but others won't. If you want to increase your international value, you have to certainly produce quality product. If you don't produce, people shall buy from others. This happens. So I say government least bothers about quality because government does not care for engineering and engineering products. And companies are only interested in money making. Those who are serious companies, certainly they give good product. But now that time has gone, then we should say this is an international company, we have to trust it. That time has gone. Whether you are national, you are international, it has no value now until you provide good products. Nobody believes in quality these days, and that's a fact one. Maybe few percentage people are there who work, but people are more or less business oriented and they believe in shortcut methods of making money and no long-term vision stands these days. Long-term vision doesn't stand these days, doesn't have any value. That's why I say professional engineers never ever bother. Professional engineers never ever bother because they have gotten no independent standing and are unable to fight against abuse of quality system, tacitly support misleading publicity. Professional engineer, when I say, this means engineer who keeps in profession. It doesn't mean that a qualified one, only educationally qualified. It doesn't mean that. Education qualified plus experience, or you can say plus habit of learning more and more. Only experience is not enough. You cannot simply count on experience of so many years and that experience is only do repetitive job or to do more and more job based on more and more learning or more teaching. Engineer is such a branch, engineer is such a field where if you work, you have to learn something every day or you have to teach someone something every day. No engineering knowledge remains constant. Every day you learn something in whatever way. Maybe in 24 hours you learn at least 1 or 2 hours something. Otherwise, sometimes we don't even know we learn. So what I say, professional means who engages in knowing more and more developments in field of engineering. And that's what I say, profession during professional activity. We learn so many items sometimes we never knew before. We know so many specifications we never knew before, and particularly when you're very fresh or budding one in engineering, construction or engineering designs, you come to know about many more research works and materials, and also we know more and more machines come in for more and more purposes. It's all part of learning, more and more materials with better specifications, and of course you can say you see many people working with you or you work with them, and they indirectly also give you certain knowledge about how to work which you never worked yourself. So we can say these engineers may be called professionally not by certification but by experience, by knowing more and more. They never bother, but those engineers who are serious, they for sure bother. And those companies who trust in engineering, who can claim they are engineering companies, you will always find quality produced by them is more reliable. It cannot be pinpointed, but this is only consideration, because those who are really professional companies, professional organizations, they respect themselves. They check themselves, they improve themselves. They don't want some command from others. And they are professionals because they know they don't want their product be defective or ill performing. There are some companies, but not very common, because when quality is ignored, I mean to say, I don't blame young generation, but it's a fact that they're not taught well, they not value well, and they are interested in fast making money, but which they forget that won't come into their life forever. We can say engineers are now well trained. They're now well trained to an extent quality is concerned, because quality cannot be learned in theory alone. And computers use cannot bring quality input into products. That's a fact one. Means I can't train you, you can't train me. Or we can train you, you can train me, it depends. It depends on what's my competency and what's your competency. But whatever it is, training should be continuous self-learning. You can say training means self-learning also, or acquisition of knowledge by self-attempts, reliable knowledge and knowing it. And I can say, so you feel at time that you have completely rehauled yourself in knowledge. You compare it yourself, what you know it now, and what you know when you came out of university. There's a difference of, you can say, different grades. I would say quality has something to do with everyone. It has to do with everyone. It has to do with designers, with site workers, and with contracts. Both contracts and engineering are related. When I say contract, it doesn't mean normal contract. It means a specific contract. I'm not talking of very normal contracts. I'm talking of contracts. I talk of contracts that are technically filled with information, engineering-wise technically oriented, and its actions and its effects, contracts implications, contractual, you can say performance, all depend on what you consider, what you understand about contract. When we talk of technical work, contract is a technical work. In fact, contract, when we say this is a contract between my company and this owner, and this is engineering contract or this is construction contract, that contract is full of technicalities. Okay, price is fixed, I understand. Price is fixed, I have agreed this price. In that case, I can say it's a question of owning responsibility. I agreed with this price, nothing wrong with that. We'll do it. But it is a technical contract, because work is technical. Work is engineering. Price doesn't matter if I have to do it. That's where I say when I talk of material, when I talk of concrete, and concrete becomes major part of contract. So we can say we talk of different world. It is technical contract in fact, because in this contract so many technical documents are involved. Maybe there are 2 or 3 or 4 or 5 or 10 pages of contract, but there will be thousands or hundreds of pages of technical work, drawings, detailings, concrete details, materials, specifications, all those documents which may amount to hundreds and hundreds and thousands. I used to talk sometimes when I discuss with people that I could not learn any practical issues, practical results. I couldn't get results from university. When I joined field, I didn't know what to do. I didn't know what I had to do. And I started learning that self in field of sites. And if you compare now, when I was in university, I think I got multi times learning from that. If you compare, I learned in field only and not in university. University, okay, I learned theory. Through tutorials I learned more, and that was just a part of training. By field, I learned everything. That's what is the point. Well, I'm not going to continue on this for long, because point is not the space. Point is about, I was talking last time of some quality issues, which I go back to them now. I refer to concrete weather conditions, means what's the relation between concrete and weather. I was just interested in that. Of course, it was a very short study, short references I collected. I'm going back to that so that technical importance continues, and I think it is facial is also very plus. And here is the concrete. It is, I'm saying, we did a guide to visual electrical concrete finish. Rather than it's a possible only concrete. I think cold weather concrete, which pages let me see. I can. It is only, I think, 1 of 9 pages. I did that one. Happens when it happens, quality PDF. Where is that page gone? I don't know. Yes, it's here. It says though I've studied this, but let us repeat it. Again I repeat it because we forget sometimes. Oh, it's not complicated, it's very easy. It says what happens when concrete freezes. Though it's not very complicated, we understand that. It's only principle in fact. We say weather conditions at job site. It is hot weather or cold weather. It's windy or calm. It's dry or humid. Whatever it may be, these conditions impact on concrete. Can say may be vastly different from optimum conditions. Assume that time a concrete mix is specified, designed or selected. Means when you design some concrete mix, or you issued its specification, you designed it, and whatever it is, it varies from laboratory conditions in every way. Laboratory conditions in which concrete specimens are stored and tested is the difference between what's actually done. Concrete can be placed in cold weather conditions provided adequate precautions are resorted to alleviate adverse impacts of low ambient temperature. Just like high temperature is not good for concrete, same way low temperature is also not good for concrete. And there is some reference from an institute, we know that's ACI, American Concrete Institute, which also defines about cold weather concreting, that in reference ACI 306, and it defines what is that one. We have already defined that, but what we say here is that all concrete must be protected from freezing until it has reached a minimum strength of whatever specified. And if concrete freezes while still fresh or before it has developed sufficient strength to resist expansive forces associated with it, associated with its freezing water, ice formation results in disruption of cement paste. Ice formation results in disruption of cement paste matrix, causing an irreparable loss in strength. And you can say if it freezes, it can result in reduction up to 50% in ultimate strength. 50% reduction can be. Once concrete has attained a compressive strength, whatever is required is generally considered to have sufficient strength to resist significant expansion and damage if frozen. So you can say definition is there of temperature, we already know it. So what we say, protection while concrete is placed, consolidated and finished. They have used word consolidated, okay, it's different world in different country. We have to know what does it mean. Exposure of concrete to cold weather conditions, extend time required for it to reach initial set, means initial time of setting is automatically impacted upon, which require finishing crews to be available for a longer period depending on actual ambient temperature. Protection of a concrete placement may require use of windbreaks or enclosures or supplementary heat. Also appropriate to adjust concrete mixture constituents for effect of ambient temperature on setting time, which may require an increase in cement content or use of an accelerating chemical admixture of both. So these are certain points we are just reconsidering. And we can say why? Because windbreak protects concrete and construction personnel from biting winds that cause temperature drops and excessive evaporation. You may say 1.8 meter or 2 meter height is enough for windbreaks, which can help, and also taller is better. Depends on what existing velocity of wind is, what's temperature, ambient temperature at that time, and what is relative humidity factor at time when we place concrete. We can say enclosing that area, or you can say heated enclosures are very effective for protecting concrete in cold weather conditions, but it's expensive because you have to spend money on wood or canvas tarpaulins or polyethylene, or you can say prefabricated rigid plastic enclosures also available. So we can say you can use also heaters. Types of heaters used are cold weather conditions. In construction, this can be direct fired, it can be indirect fired, or hydronic system. You can say to avoid carbonation of fresh concrete surfaces, indirect fire heater should be used. If concrete is not exposed to heater or exhaust directly, a direct fire heater is stable. Caution should be resorted to. Make sure that workers are not overexposed to carbon monoxide. Thing is you can say curing not only requires adequate moisture, whereas we specify curing not only requires adequate moisture but also appropriate temperature. You have to, likewise, you have to understand all these, and we have in the file. I don't want to go on repeating this. Other file, and it is here. This is concrete weather conditions. In this file, you can say just one page it was, and it's all. It says cold weather concreting. It says cold weather concreting. Special care must be taken when concrete is cast in winter. If water in young concrete is allowed to freeze, concrete shall be damaged to such an extent that it is unfit for use. Even if temperature does not drop below zero, concrete shall not gain strength as quickly as it would during warmer months. This is what it says, and temperature is given here. It says that strength when it is 5 MPa. What it says that temperature of concrete should not fall below 5 degrees Celsius at any point until strength has reached 5 MPa. No temperature should fall below 5 degrees Celsius. Then you can say workmanship clause says execution of concrete rather than in design code and follow same requirement. Surfaces to be in contact with newly placed concrete, including subgrade materials, need be few degrees above 2C, freezing 2C. Reinforcing bars or other embedded metal must be free of ice and snow, but otherwise there remains generally no restriction on temperature prior to casting. ACI 306, which is referred to, suggests that embedded steel greater than about 25 mm diameter or 1 inch should have a temperature of at least -12, not -12, so 12, okay. Water curing should not be applied in conditions where freezing of concrete is anticipated. So we should not use water there because it says 12 degrees Celsius. So thus certain precautions require to be taken in concrete in cold weather conditions. When planning to cast concrete, formation on likely temperature can be obtained from where our office or metallurgical department as well. Contract knows it. You can say some suppliers of ready-mix concrete are able to supply heated concrete also, which can be supplied to site at temperature above 10 degrees Celsius. That's good one, in fact, even in coldest weather. Concrete should be transported and placed as quickly as possible to avoid heat loss. All plant should be protected against frost, while smaller items being kept under cover when not in use. Concrete temperature says ready-mix concrete that is delivered should not be below 5 degrees Celsius at time of delivery. Should not be placed against formwork or reinforcement covered in ice or snow. This is a point to remember. Once setting process starts, heat of hydration help to maintain temperature of concrete. Timber formwork usually offers sufficient insulation. However, steel formwork is poor insulator An insulating material should be fixed to back of form. Once cast, exposed concrete surfaces should be covered with insulating material. Exposed concrete surfaces should be covered with insulating material. It should be noted that reduced temperature shall lead to a slower rate of gain of strength of concrete. Hence, curing and striking times have to be extended. Particularly affects concretes and cement's replacement of material, and that can be GBS and fly ash. This is one file I tried to reference to. I'm closing this file to get another file open, and that is, what we say, this diaphragm. So there was a guide to, sometimes concrete hot weathers, concrete precautionary tips for pouring concrete. Let's take this one first. It is what says concrete precautionary tips for pouring concrete. Says well, there's some. I repeated this before also, but I'm just telling you some points for refreshing. It states that there are some mistakes we have to avoid when working with concrete in cold weather. And it says when temperature fluctuates, concrete is subject to different curing conditions, resulting in sporadic strength gain. Contractors must prepare long before weather changes to adequately protect fresh concrete. Having right equipment ready to use at job site, such as tarps and blankets, can help avoid unnecessary delays and unsafe concrete development. When it says concrete with different temperature gradients doesn't develop strength adequately, leading to cracks and possible structure damage, disaster. When placing your concrete, placement of slab factors into effectiveness of concrete curing conditions. Frozen ground can settle when thawed. Causing concrete to crack. Fresh concrete closest to ground also cure slower than surface concrete, meaning top portion of slab set while bottom does not set at same time. And you allow concrete to freeze, that's another mistake. Concrete should be kept warm in order to cure properly, and that temperature is around 10 degrees Celsius. Though it's not warm, but in language of temperature, concrete can be called good at about 10 degrees Celsius. Fresh concrete can freeze at -4 degrees Celsius. Fresh concrete can freeze at -4 degrees Celsius. That's why it's important to warm fresh concrete until it has proper compressive strength measurement. And this can be done better using a concrete temperature meter. Then we have using cold tools. Cold tools, just important to keep your tools and building materials, forms or tools are too cold. It could alter concrete that comes into contact with them. So you can say this can negatively affect strength development of your slab. Then you can say another mistake is not using heaters. Concrete requires to stay warm in order to continue curing and develop strength. If you gets cold, too low in temperature, curing stops altogether. Portable heaters deliver extra heat into ground and directly on concrete, ensuring concrete keeps curing and gaining strength. Yet care about when using heat. Improperly heating concrete can result in weak structures, and your seal concrete when it's too cold outside. Concrete sealers make your concrete more resistant to weather, exposure, and other outside elements. If concrete is placed in cold weather, it's wise to get sealer that works well in extreme weather conditions based on recommendation of producer, manufacturers. Sealing typically should not be done if temperature is below 10 degrees Celsius. Of daylight lessons. Temperature monitoring cold weather is important to ensure production of high quality concrete that meets thermal control plan specifications. If proper attention is not given to strength development of concrete, several common problems can occur. Among these problems are freezing of concrete at early ages, freezing of concrete, lack of required strength, rapid temperature changes, inadequate protection of structure and its serviceability, and improper curing procedures. Concrete in winter can be avoided by using real-time temperature sensors to ensure optimal temperature of concrete is maintained during curing stages. Making sure concrete doesn't freeze, temperature differential is maintained. Concrete doesn't freeze, temperature differential is maintained under specific limits. Then maximum temperature does not achieve maximum limits, and concrete gains strength properly are important in whatever mass concrete applied for cold weather. This was what it says, for example, is reference. According to many construction experts working on concrete, cold weather is certainly difficult. Pouring can be difficult, as also being exposed humidity and wetness of cold weather. Frozen layer of subgrade shrinks when it thaws, When it's directly in contact with concrete at its below stone course, it shall affect bearing integrity of some degree. We can say, is it safe to pour a concrete building also onto compacted gravel base at rest of frozen? So there are so many such questions and we can answer them. So no problem, we can close this file as well, and I can refer to, I don't know whether this file precautionary tips, and there was a concrete guide to visual architecture. You can say concrete technology. I opened a file which is used for defining concrete. It's of course definitions, terminology that we use in concrete, but it's a very important one. We have to, and this is concrete terminology. Concrete terminology we can say. What does it mean? AF ratio, what does it mean? Size. Molar or mass ratio. AF ratio, molar or mass ratio of aluminum oxide. I'll blow up a little more so that we can go better. Concrete terminology. This is from ACI CT 21. AF ratio is molar or mass ratio, that is of aluminum oxide Al2O3 to iron oxide Fe2O3 as in Portland cement. So A stands for Al2O3 and F stands for iron oxide. This is called, or you can say, ratio of mass ratio of aluminum oxide Al2O3 divided by iron oxide Fe2O3 as in Portland cement. Now general definitions are here, terminology, so it's not sequenced, it's alphabetically provided here. Abraham's law says a rule stating that with given concrete materials and conditions of test, ratio of amount of water to amount of cement in mixture determines strength of concrete, provided mixture is of a workable consistency. And we can say water cement ratio, Abraham's law is, again I am repeating, rule stating with given concrete material and conditions of test, ratio of amount of water to amount of cement in mixture determines strength of concrete, provided mixture is of workable consistency. Abrasion damage. Abrasion, wearing away of a surface by rubbing and friction. Wearing away of surface by rubbing and friction is called abrasion damage. Wearing away of surface by rubbing and friction. Videos and audio signals have fallen. I hope video doesn't stop and it's not working. There is another one, absorption. Absorption. My voice may not be recorded. Let me continue. Some signals are there now. Some signals. Let's say absorption. There are also two, that is process by which a liquid is drawn. Absorption is process by which a liquid is drawn into and tends to fill permeable voids in a porous solid body. This is number one. Process by which a liquid is drawn into and tends to fill permeable voids in a porous solid body. That is absorption. And also increase in mass of a porous of a porous solid body resulting from penetration of a liquid into its permeable voids. Increase in mass of a porous solid body resulting from penetration of a liquid into its permeable voids. Abutment in bridges and foundation that is typically constructed with concrete that supports superstructure of bridge. Other one is in dams side of gorge or bank of a stream against which a dam abuts. In dams side of gorge or bank of stream, side or gorge or bank of stream against which accelerating admixture it is. Accelerating admixture is a signal drops continuous, both video and audio, 0, 0. Accelerating admixture, an admixture that causes an increase in rate of hydration. An admixture that causes an increase in rate of hydration of hydraulic cement and thus shortens time of setting, increases rate of strength development or both. It is called accelerating admixture, or you can say it accelerate rate of hydration. Definition says admixture that causes an increase in rate of hydration, hydraulic cement, rate of hydraulic cement and hydration of cement and thus shortens time of this is a, okay, I see. So it is accelerating admixture defined. Again, signals continuous to valve. I don't think I'll have to continue 7 FPS and 0, 0 video and audio. 7 FPS means it won't work. I'm waiting. If I got signals back, I'm not sure if I got signals back or 7 FPS. Some signals, let us say, acceleration, FPS is 3, is again very low. Okay, something. Acceleration, increase in rate of natural progress of setting. Increase in rate of natural progress of setting or hardening of concrete. Accelerator and accidental here. We are now going to acid etching. Removal of cementitious surface. Removal of cementitious surface through controlled dissolution. Controlled dissolution to expose sand or aggregates. Very easy. I say removal of cementitious surface through controlled dissolution to expose sand or aggregate. Roughen a smooth cementitious surface. Roughen a smooth cementitious surface in preparation for cementitious coating material application. Or create art, create design, or create an architectural finish. I repeat, acid etching is a process of removal of a cementitious surface through controlled dissolution to expose sand or aggregate. Roughen a surface, roughen a smooth cementitious surface in preparation for cementitious coating material application, or create art, create design, or create an architectural finish. Acrylic resin. Acrylic resin. One of group of thermoplastic resin. One of a group of thermoplastic resins formed by polymerizing esters, polymerizing esters of amides of acrylic acids. It says acrylic resin, one of group of thermoplastic resins formed by polymerizing esters or amides of acrylic acid used to make polymer modified concrete and polymer concretes. Says, again I say acrylic resin, one of group of thermoplastic resins formed by polymerizing esters or amides of acrylic acid used to make polymer modified concrete and polymer concrete. Active crack, a crack whose width changes with time. A crack whose width changes with time. So I expect something. Continue. A material that's addition, a material that is interground, or blended, interground or blended in limited amounts into a hydraulic, a material that is interground or blended in limited amounts into a hydraulic cement during manufacture, either as a processing addition to aid in manufacturing and handling cement, or as a functional addition to modify properties of finished product. This is definition of addition of something, and it's called the material that's interground or blended in limited amounts. A substance added to another. A substance added to another in relatively small amounts to impart or improve desirable properties or suppress undesirable properties. This is called additive. A substance added to another one, a substance added to another one in relatively small quantity or amount to part or improve desirable properties or suppress undesirable property. Adhesion, state in which two surfaces are held together by internal effects that may consist of molecular forces, interlocking action, or both. Here is adhesion, state in which two surfaces are held together by internal effects that may consist of molecular forces, interlocking action, or both. It is adhesion. You can say adhesion, then adhesives. Group of materials used to join or bond similar or dissimilar materials. For example, in concrete work, epoxy resin. It is adhesives. We were talking of group of materials used to join or bond similar or dissimilar. Adhesives means group of materials used to join or bond similar or dissimilar materials. For example, in concrete work, it is epoxy resin. Now, adiabatic, a condition in which heat neither enters nor leaves a system. It's called adiabatic. So we can say adiabatic is a condition which heat neither enters nor leaves a system. Some things sometimes are very interesting, Then we go to adsorbed water. Adsorbed water. Water held on surfaces of a material. Surfaces of material. Water held on surfaces of materials. For example, here is adsorbed water. Water held on surface of a material by electrochemical forces. Mind it, we are talking absorbed water. Water held on surfaces of a material by electrochemical forces and having physical properties substantially different from those of absorbed water. Is absorbed water we are talking, not absorbed water, held on surfaces of materials by electrochemical process and having physical properties sustainably or substantially different from those of absorbed water. So what is our definition of adsorbed water? Again I say, because there's confusion in this. A water held on surface of a material by electrochemical forces and water held on surface of a material by electrochemical forces and having physical properties substantially different from those of absorbed water or chemical combined water to at time some temperature and pressure. Adsorption. Development of a higher concentration of substance. Development of higher concentration of substance at surface of either a liquid or solid. Then exists in bulk of medium. Process by which a substance is adsorbed. It can say that as absorption is defined, development of a higher concentration of a substance at surface of lower there whatever we can say development of a higher concentration of substance at surface of either liquid or solid, such as cement paste or aggregate. Slope grouting. Advancing slope grouting. Advancing slope grouting. A method of grouting by which front of a mass of grout is caused to move horizontally through pre-placed aggregate by use of suitable grout injection sequence. Advanced slope grouting, it says. It's full charged. I think I should keep down this fully charged. So advanced slope grouting is a method by which front of a mass of grout front of a mass of grout is caused to move horizontally through pre-placed aggregate by use of suitable grout injection sequence. Advancing slope method. Method of placing concrete. Method of placing concrete lining in which face of fresh concrete is not vertical and moves forward as concrete is placed. Method of placing concrete as it is done in tunnel linings in which face of fresh concrete is not vertical and moves forward as concrete is placed. Aerated concrete. We can say cellular concrete and formed concrete. F-Willit. F-Willit. This is AFWILLIT. F-Willit. A mineral which hydrated Portland cement mixtures. F-Willit it is called. 3CaO. This is chemical composition. This is a mineral with 3CaO, 2SiO2 and 3H2O. This is F-Willit. Agent is general term for a material that may be used either as an addition we can say agent, a general term for a material that may be used either as an addition to cement or an admixture in concrete. An air entraining agent, for example, is that agent. So we know F-Willit, that is fully charged, so I put it on charged situation so that battery is not impacted again. And let me put my shoes also in because it's very cold. I can't tolerate cold, that's my problem. I can't tolerate hot, I can't tolerate cold. It's my nature because I worked in hot long ago. I worked in hard weather conditions in Gulf countries, in Middle East countries. A ball or mass is aggregation. Aggregate. Aggregate. Aggregate is very simple. We define signals. Again, a problem. My God, I'm fed up. I sometimes speak, maybe it's not recorded. What to do? I can't have gap all time. Aggregate is granular material. It is a granular material such as sand, gravel, crushed stone, crushed hydraulic, cement, concrete. Slag used with cementing medium to produce either concrete or mortar. This can be aggregates can be heavyweight aggregate as well as lightweight aggregate. Definition of aggregate is very simple: granular material aggregate and lightweight aggregate. Then we have here aggregate blending. Aggregate blending. Process by process of intermixing. Process of intermixing two or more aggregates. Process of intermixing two or more aggregates to produce a combination with improved grading or other properties. Aggregate blending is defined process of intermixing two or more aggregates to produce a combination with improved grading or other properties. Aggregate interlock. Effect of portions of aggregate particles. Effect of portions of aggregate particles from one side of a joint or crack in concrete protruding into recess in other side of joint or crack to transfer load in shear and maintaining alignment. Aggregate interlock, again we see, is important definition. Effect of what? Portions of aggregate particles from one side of a joint or crack in concrete protruding into recess of resist in other side of joint or crack to transfer load in shear and maintain alignment. Aggregate interlocking. Very simple. There are recesses somewhere, maybe cracks somewhere. So you can say this is an effect. Aggregate particles to enter into another site and the crack or joint, so that you can say into other one says concrete projecting into resist in other side of joint or crack to transfer load in shear and maintain alignment. So interlocking of aggregates helps shear forces to transfer loads in shear and maintain alignment. Aggregate transparency. Aggregate transparency, that is discoloration of concrete surface consisting of darkened areas over coarse aggregate particles immediately below concrete surface. Discoloration of concrete surface consisting of darkened areas over coarse aggregate particles immediately below concrete surface. Again, it's a little confusing. Discoloration of concrete, we're talking of aggregate transparency. Discoloration of concrete surface consisting of darkened areas over coarse aggregate particles immediately below concrete surface. Aggregate cement ratio. Ratio of total aggregate to cement, either by mass or volume. That is aggregate cement ratio. Agitating speed. Rate of rotation of drum. Rate of rotation of drum of a truck mixer or agitator when used for agitating mixed concrete. It says aggregate cement ratio, that's total aggregate to cement either by mass or volume, and agitating speed, rate of rotation of drum of a truck mixer or agitator when used for agitating mixed concrete. Agitating truck, a vehicle in which freshly mixed concrete can be conveyed from site of mixing to site of placement. While being agitated, truck body can either be stationary and contain an agitator. A vehicle in which freshly mixed concrete can be conveyed from site of mixing to site of placement. While being agitated, truck body can either be stationary and contain an agitator, or it can be drum rotated continuously to agitate. See, says vehicle in which freshly mixed concrete can be conveyed from site to work site while being agitated Truck body can either be stationary or not. Can say that is truck agitating body vehicle which freshly mixed concrete can be conveyed from site of mixing to site of placement while being agitated. Truck body can either be stationary or and can contain an agitator, or it can be drum rotated continuously to agitate contents called agitating lorry in United Kingdom. Agitation. You can say agitator, or when I say agitation, process of, you can say process of motion in mixed concrete just sufficient to prevent segregation or loss of workability. Process of providing motion in mixed concrete just sufficient to prevent segregation or loss of workability, and also mixing and homogenizing of slurries, or finely ground powder by either mechanical means or injection. And it is also agitation. It is for fine material mixing and homogenization of slurries or finely ground powders by either mechanical means or injection of air. Agitator is a device for maintaining workability. Agitator is a device for maintaining workability and preventing segregation of mixed concrete by agitation. Air content. Air content, volume of air voids in cement paste. Volume of air voids in cement paste, mortar or concrete, exclusive of pore space. Exclusive of pore space in aggregate particles. Usually expressed as a percentage of total volume of paste, mortar or concrete. Volume of air voids in cement paste, mortar or concrete, exclusive of pore space in aggregate particles. Usually expressed as percentage of total volume of paste and volume of paste, mortar or concrete. So we can repeat: volume of your voids, cement paste, mortar, concrete, exclusive of pore space in aggregate particle, usually expressed as a percentage of total. Says air and training. Capability of material or process to develop a system of microscopic bubbles. Microscopic bubbles of air in cement paste You can say cement paste, mortar or concrete during mixing. Here in training is capability of material or process, metal or process to develop a system of microscopic bubbles. Microscopic bubbles, microscopic bubbles of air in cement paste, mortar or concrete during mixing. Capacity of material, capacity of material or process to develop a system of microprocessor. Then we can say here in training is capability of material or process to develop system of microscopic bubbles of air, microscopic bubbles of air in cement paste, mortar or concrete during mixing. Air entrainment, incorporation of air in form of microscopic bubbles. Incorporation of air in form of microscopic bubbles, especially smaller than 1 mm. So incorporation of air in form of microscopic bubbles which are typical than 1 mm and 5. We have here less than 1 mm, which is smaller than 1 mm, that is incorporation of air in form of microscopic bubbles, typically is smaller than 1 mm. During mixing of either concrete or mortar. Airlift equipment whereby slurry or dry powder is lifted through pipes by means of compressed air, that is airlift. Equipment whereby slurry or dry powder is lifted with airlift is equipment whereby slurry or dry powder is lifted through pipes by means of compressed air. Air meter. This is 641. Okay. Air meter. Pore space in aggregate particles. Pore space in aggregate particles is usually expressed as percentage of total volume of paste, mortar or concrete. Air content, volume of air voids in cement paste, mortar or concrete exclusive of pore space. mortar or concrete, exclusive of pore space, volume of paste, mortar or concrete. Air and training. Air and training. Air and training. I have to go up for a couple of minutes. Just finish this. Air and training. Capability of material or process. Capability of material or process to develop a system of microscopic bubbles. Capability of a material or process to develop a system of microscopic bubbles. Capability of material or process to develop a system of microscopic bubbles of air in cement paste, mortar or concrete during mixing. That is air and training. Capability of material or process to develop a system of microscopic bubble of air in cement paste, mortar or concrete. Air entrainment. Air entrainment, incorporation of air in form of microscopic bubbles, typically smaller than 1 mm. Airlift equipment whereby slurry or dry powder is lifted through pipes up by means of compressed air. And air meter, a device for measuring amount of we can say airlift is there, then air meter, a device for measuring air content of concrete and mortar. A device for measuring air content of concrete and mortar. Air ring, that is perforated manifold in nozzle of wet mix shotcrete equipment. Perforated manifold in nozzle of wet mix shotcrete equipment through which high pressure air is you can say air ring. Perforated manifold in nozzle of wet mix shotcrete equipment through which high pressure air is introduced into material flow. We have then air separator. Just give me some minutes, I'll be back and do it. दिया यार, ये मतलब सिखा रहा है मुझे, पता नहीं क्या दिया भी यार पोजीशन। मैं क्या करूँ, जानते नहीं पोजीशन क्या होती है डायग्राम को। ये तो पोजीशन। Well, it's here we can say here is air separator. Air separator is a 6:55, so I have to close it in just 5 minutes. Maybe I can close now, but no problem. Let's go for 5 minutes more. No problem. Air separator. It is an apparatus that separates various size fractions. An apparatus that separates various size fractions of ground material pneumatically. Right? What does it say? That separates various size fractions of ground materials pneumatically. Fine particles are discharged as product and oversized particles are returned to mill as tailing. So called air separator, which separates various size fractions. Apparatus that separates various size fractions of ground materials pneumatically. Fine particles are discharged as product and oversized particles are returned to mill as tailing. An air void is space in cement paste or in mortar or in concrete filled with air. Air blown mortar, shotcrete we can say, and you can say that is blast furnace slag, and air and training admixture. Air and training mixture, and admixture that causes development of system of microscopic air bubbles. An admixture that causes development of a system of microscopic air bubbles in concrete. Microscopic air bubbles in concrete, development of that, and that admixture is called air and training admixture that develops microscopic air bubbles in concrete, mortar or cement paste. During mixing, usually to increase its workability and entrained air containing entrained air within specified limits, or you can redefine it, hydraulic cement containing sufficient amount of air entraining agent to produce a cementitious mixture containing air entrained or entrained air within specified limit. Air permeability test, procedure for measuring fineness, procedure for measuring fineness of powdered material such as Portland cement, or Blaine test, air permeability test. Air water jet, high velocity jet of air and water mixed at nozzle used in cleanup of surfaces of rock or concrete. such as horizontal construction joint, air water jet, alignment wire, ground wire, allied, calcium silicate, that is principal phase in Portland cement, tri-calcium silicate, that is principal phase in Portland cement clinker, alkali, that was alite I discussed. Now alkali, salt of alkali metals, principally sodium and potassium. Sodium and potassium, especially sodium and potassium, occurring in constituents of concrete and mortar, usually expressed in chemical analysis as oxides Na2O and K2O, also is called alkali metals, principally sodium and potassium, specifically sodium and potassium, occurring in constituents of concrete and mortar, usually expressed in chemical analysis as oxides Na2O and K2O. Alkali, alkali reactivity of aggregate, susceptibility of aggregate to alkali aggregate reaction. Alkali aggregate reaction, it's chemical reaction. Alkali aggregate reaction, it's chemical reaction in either mortar or concrete between alkalis, that is sodium and potassium, from Portland cement or other sources, and certain constituents of some aggregate. Alkali alkalis, that is sodium and potassium, in Portland cement, and certain carbonate rocks, particularly calcitic dolomite and dolomite. Carbonate rocks, particularly calcitic dolomite and dolomitic limestones, present in some aggregates. Reaction between alkalis, which are sodium and potassium, in Portland cement, and certain carbonate rocks, particularly calcitic dolomite and dolomitic limestones, present in some aggregates. Alkali silica reaction. Reaction between alkalis, sodium and potassium, in Portland cement and certain siliceous rocks or minerals such as opaline chat, strained quartz and acidic volcanic glass present in some aggregates. That is alkali silica reaction between alkalis, sodium and potassium in Portland cement, and also certain siliceous rocks or minerals such as opaline, chat, strained quartz and acidic volcanic glass present in some aggregates. Alkyl aryl sulfonate. Alkyl aryl sulfonate is synthetic detergent used to entrain air in hydraulic cement mixture. Alkyl aryl sulfonate, synthetic detergent used to entrain air in hydraulic cement mixture. Allowable bearing capacity, maximum pressure to which a soil or other material should be subjected to guard against shear failure or excessive settlement. Maximum pressure to which a soil or other material should be subjected to guard against shear failure or excessive settlement. Allowable load, that already is done, dead load or service live load. Allowable stress, maximum permissible stress used in design of members of a structure and based on a factor of safety against rupture or yielding of any type. Maximum permissible stress used in design of members of a structure and based on a factor of safety against rupture or yielding of whatever type. Alternative cement, an inorganic cement that can be used as complete replacement for Portland or blended hydraulic cement. That's not covered by applicable specifications for Portland or blended hydraulic cement. Alternative cement, an inorganic cement that can be used as complete replacement for Portland or blended hydraulic cements, and that's not covered by applicable specifications for Portland or blended hydraulic cements. Alumina is aluminum oxide, Al2O3. Aluminate cement, that is calcium aluminate cement, and aluminate concrete is concrete made with calcium aluminate cement. Aluminous cement is calcium aluminate cement. Amount of mixing, extent of mixer action, says amount of mixing, Extent of mixer extent of mixer action implied in combining ingredients of for either concrete or mortar. In case of stationary mixers, mixing time in case of truck mixer. Number of revolutions of drum at mixing speed after intermingling of cementitious materials with water and aggregates is same. Amount of mixing, extent of mixer action, extent of mixer action employed in combining ingredients for either concrete or mortar in case of stationary mixers. Mixing time in case of truck mixers, number of revolutions of drum at mixing speed after intermingling of cementitious materials with water and aggregates, and amplitude maximum displacement from mean position in connection with vibration. We have gone through certain terminology of materials, or you can say engineering materials, that are mentioned in ACI. This is page 5 of this note, and we today conclude here. Tomorrow we'll see continuation of this after talk of quality, and this shall be page 6, and I see we go back to quality, and of course we go back to certification, we go back to quality, we go back to this file again and again, and for time being now I'm going to close it for sure, because already 3 hours have passed. I hope you like it, enjoy it. Thank you very much. We'll see you again